Nice to meet you to this new episode of Weekbits. On my kitchen table, the well-known Yamaha RX-E810. But it's a little bit bent here, and yeah, there's something missing. Yeah. What is going on with this machine? I don't know. No information, like ever. And here we have the insert the plug into the 230 volts AC, and there's no input. Maybe only the fluorescence display is turned off. Oh no, nothing. Left, right, treble. Nothing. Yeah. Looks like a failure inside. We would like to open it. Here we got it's very heavy. This machine, this 810 is very heavy, so I must take this. Oh, there's something inside, a screw. But from which machine? Interest, huh? And we must open it first. And yeah, I don't know what's happened with it. Now we have here 4 black one screws. Interesting. 4 black one screws. And important, disconnected from the mains. If you open a box or a thing, I cannot say often enough, but it is a must that you disconnect it about the high risk of electrical shock. And if this is, yeah, then you can call the ambulance. I don't know how electrical shock is working, but it's hard for the heart. But now we'd like to see in this machine. But is it not possible to doing with the assembly course what I'm doing to making a switcher, 8-time switcher for 8 inputs and 8 outputs, and making an amplifier with a look? It's bent. Oh my gosh, it's banded. Someone open it. And interest wise, yesterday during I'm look, super built, really. A big transformer here we can see, and here is the transformer. Boah, and it's heavy, really. You cannot believe it's really heavy. What I see was interesting. Normal the capacitor of here. We change the capacitor. This is the capacitor. This capacitor will be a red one also. No, it's a blue one. I don't change it. No. Normally, it's this capacitor defect here from the power supply. This is very often. I don't know why it's interrupted or so, and the power supply doesn't start. It's a main failure source is the power supply, but not the master power supply. This one, it's only the second power supply. This is for the remote control if it's in standby. How we would like to measure pin 10. It should be 2, 4, 6, 8, 9, 10. Here should be 10 volts, but we see it's not 10 volts. Sometimes interrupted. And if I push here, it comes from this power supply here. Oh, we must search the failure there. I think I disconnected from the mains, and we are switch out here, and we lift this board out and have a watch on it. Maybe we have there a failure. Look here. In future I will remember the C8 told me we should change this capacitor, but where is the C8? It is changed or it is not changed? Looks like it is changed. Interesting, why not 10 volts are coming out? Maybe they are cold. They're all cold. The C8 is changed. C11 is the blue one, and yeah, we don't know why it happened this. Maybe I have a second board. This is also wrong. What I found out is also this. I must show you that. It's under it. It's this inside here. You cannot see that. It's a transistor, and it looks like that it is not connected. I think I must build all this out, but I think I can also solder it through here, through the I can solder it through this. Very funny, never solder like this. Yeah, it's now soldered. It was not good soldered. I see that with my radar eyes. Maybe now it's running. I'm wondering because this was on this side. So the first thing what we're gonna do is also we check up the fuses, and we go there and we making the and the beepsy. You can hear that. It's beepsing. Okay, it's okay, it's okay. Yes, it's okay, it's okay. This is changed. What can there be here? Is nothing, only this or this? It's coming out only at less volts. Maybe the solder joints are bad or whatever. We solder around, but we cannot measure. What shall I do? It's interest, huh? Why is this so? Maybe this transistor is defect. I have one defect of this transistor. I changed one time this transistor and it switched on and off with this clock cycle from this IC3 here, and maybe this is wrong. I solder all the cold, here are all cold joints, solder joints. That we do first. Then we're searching again where it can be and change the parts. But it is not fun here to change the parts. In case of that we must build it out and build it in and so on and messing around. A second working supply for this was super. Also I have a transformer here. It was defect. A defect transformer, you must know. This transformer was one time defect. But I don't know, is it defect or not, making no click and so on. This is suspect. And also we're changing these optocouplers here, what I'm soldering now. Maybe there is a mistake, huh? First we solder all, And here we must have the 10 volts on this C4. You know? I know that now. Oh, what is here? Here is a broken solder joint. It's broken. Why? Not good. Maybe this was the failure. Okay. Low supply energy, and we go. Here we put it in and hope so that is working. But if it's working now, then I don't know what's happened with it. This is also a terrible thing, no? You see? Is it here? It's here. It's here, it's here, it's here. Oh, we press it in, click. You hear that? Why it's so looking so great. So super. It's a dangerous board. They thought they have a good construction, but it's not so good. Stand-up board, super. But maybe we need a screw on the backside for the grounding. This is also an interesting question. There was no screw on the backside. Should we take it in? This is a screw from my other machine, but we do that. Looks good. And it holds. So, click on, and what's happened? Nothing. Nothing real. And we have the same failure as before. Going to the voltage, and we have now 10 volts or not. 4 volts. We need 10 volts here. Power supply, what are you doing? This is interesting. Look what I have here. The C8 spare part. We changed the C8 in case of, I don't know. Somebody told me that I should change the C8, but why doesn't go out, huh? I don't think so. This is defect. I don't think so. I think it's a new one. It's a new one. Here's the focus. Here's my focus. Look. I built in a new one, and we have a watch. What's happened on it? Then we change it, and we hope so it is working. I soldered this in. Should be cold now. I don't know what's happened today, but my electronic doesn't work here. Cutting the leads, and then we are going to make the test for it, but I don't think so this is defect. It's only for the, we can measure this capacitor. Hope so I can measure this. Okay, no problem. We measure it later, and now we insert it, but I don't think so that's working. It's not a great deal here. I think so the transistor is defective, so we must know, and insert this here. This is the power supply cable, and that for the 230 volts, and I don't connect it now. We connect it to the mains, and nothing. No click. No click, and also have here no 10 volts. I'd like to show you this. Insert here on the ground and measure the volts, and here we have 4 volts. That means there are not so much energy is coming over the transformer, and this means maybe the transistor don't switch correct. Yeah, we would like to analyze what is doing IC3 on the power supply side. Now it's dangerous. From pin number 7 we must measure to 14, and it's 7.5 volts. Okay, you see that? I'll switch it on now, and now I measure voltage from pin 7 to this resistor. And here we have the 7.5 volts, it's okay, but on the other side we have 0 volts. Is that can it be? If the transistor is open, we have 0 volts on the other side, and if we have 7 volts, it means must be also 7 volts on the gate. Yeah, that sounds so this FET transistor is maybe interrupted, or maybe have a short to the ground or so. This is interesting. I hope so. I have a transistor here, and then we can change it and make the test.
So we are here now at the second power supply, or standby power supply, and we see here we have the voltage from coming from here to here. Here's the mains connector coming here and here in. Yeah, and the interesting is that it's running here over the transformer back to the rectifier, and here to this transistor it switches to the ground. Yeah, and this goes back, and the C11, and here it floats back, current goes back here. The thing is that this IC3 is switching, and with a clock from pin number 3 it loads up here the capacitor, and then threshold, and then it's click, and the power comes from here over this C8 C8 that we repaired. We must measure here the 7.6 volts that is for the supply. I think so this is important that we measure this. VDD, here it comes. Look, here it comes, the VDD, this 100 ohm, and this, okay, here it must be the VDD, number 14, 7.6 volts. This we measure.
Look here, from pin 7 to here, to the gate I have no volt, and to the middle I have 155 volt, and to here I have 0 volt, but this should be bridged, yeah, and here we have 0 volts. That means this transistor maybe is defect. We change it, and yeah, disconnect from the mains, and I think I built it out in case of what? In case of that, maybe this is not so, this has not the, look, it's here, this little transistor. Looks like interrupted. I mean, how can be the gate? The gate is normal high, and so here this is not high. We are so I got now a 10 ohm resistor, yeah, and I would like to bridge the transistor in case of what? In case of maybe I hear a click, and if the click, then I know the transistor is interrupted also. In all these cases you must switch the power off. It's very dangerous for you and for your fingers and for your heart. Sometimes or we burn the transistor, the resistor, we burn it now. So, on, and nothing. Really nothing. This is I'm wondering. Now I'm not surprised about this. Cannot click on. Okay, no click on, and zero volts. Here we have also 0 volts. No. Could not be, or is it? You mean the transformer is bad? It's not warm. This is suspect. I'm wondering. So disconnected from the mains, and maybe the transformer is really bad or interrupted. Kilo ohms. 3.8 kilo ohms. This is much for transformer. Then the output side, 30 ohms. Input side, 3.89 kilo ohms. 0. Okay. But is this normal? 3.8 kilo ohms? It's interest on a transformer. 3.8 kilo ohms? Maybe for the low current. I must search out a transformer. I'm an idiot. So now with the resistor and the power supply on, listen. Click. It's going click. That means this transistor is wrong. Now it's going. It's running. We must change the transistor. I would like to change the transistor here, and it's maybe easier than I think. Disconnect it from the mains here. We disconnect this, and have here also an N-type. And first I would like to solder it a little bit. Then is that clever if I do this like this here? Yeah, it was clever. Here, look, the transistor. And this is the other one that I take. I must desolder the pins. It's quite easy to do this. Desoldering it here for the... Now the holes are open, and I put that in. I hope so. My pins are okay. Look, the pins are okay. And hope so. This is the same transistor, and we hope so. Now it's working. In case of that, we connect it here to the power, and maybe the 500 volt transistor is working. Doesn't make click. This is interesting. Why? Oh, it's working. It's working. You see? Haha, super. Yes. It sounds like a horror tuner, but why it is so weak? We tune to another station. Maybe we have another station here. Here is the antenna. The antenna. I hold it in my hand. I think so. 9999 is. Oh, back. No. Oh, it's a nightmare. This tuner is not so sensitive. It needs more signal. I don't know why. But it is working. Should we connect the CD player to it? We connect the CD player to it, it's better. DVD, CD. This is what I'm connecting now, and it's working. With my Toshiba CD player. This is an old machine, look. Look here. With integrated power supply. You cannot believe it. 36 years old. The XRJ9. Yes, it's working. Skip next one. Okay, that sounds good with the new transistor. This is the 600 volt transistor here, look, the new one. 500 volts, sorry. And now I must assemble the machine. So, we stop this machine, put it there on the back side, and disconnect this. Switch it off, it works. And disconnect it from all this stuff, and don't know what we can do here. Isolate it or not isolate it. It's here. Disconnect this, and we are we connect the power supply on the back, and I also would like to insert it here, a new screw, and yes, we can do that here with this. It's also good, but no, first we must making a screw inside, And I have found one. Hope so this is okay. Is it good? No, it's not good. It's a metric millimeter screw. We need another one. Now we have another screw. Hope so this is working. Ah, no way, too big. I hope so this is working. So now we have the correct plan. So super. It was so hard to find. I test now 3 screws. It doesn't fit. Yes, but yes. I put that back. Put the top back on this machine, and it's bent. I mean, hey, come on, is that the wrong deck? No, it's correct. Look, it's bent here. It's bent to the inside and bent to the outside. And what should I say? Who's doing this? Close the deck and have no chance to fix it. But we fix it now. And this cannot be. Why it is? Ah, yes. It's bent. So hard bent. I mean, why are they doing this? So it cannot be that it is here. Maybe it's the wrong. I think it's the wrong. It's the wrong thing. It cannot fit in case of this is too high. That means this is the wrong. This is the wrong. But how I can close it now? This is never see this before. A stupid thing like this. I cannot fill it in because the slots are too too wide. Should I cut it? No. I mean, hey, come on. This is stupid. So what I'm gonna do is now I cut this and bend it out. Now we're listening to the music. That was the Yamaha RX-E810 with the power fail in the main 2 board, and we found out that we can bridge the resistor Q4 with a resistor from a 10 ohms between source and drain, and check it up that is working. But you need it for the regulation. You'd have a feedback from the secondary side to the primary side for the second power supply in case of, I think, energy consumption, lowering the energy consumption. Yes, that was it. If you like my channel, please subscribe, and I say thank you for watching.